All right, we're live, and we're gonna do this. We're gonna play a little game, okay? And I enjoy this game. On this side is the antiderivative. On this side is the derivative. And pardon? Are you sure? Okay, because I wasn't quite listening. Okay, so I will pick the first person, or no, would there be a volunteer for the first person? Gavin, okay, I'm going to ask you why you volunteered right away. My wife is the first person to volunteer for anything. Okay. Okay. You know why my wife volunteers? Because she says it's always the easiest problem. I said, really? I haven't noticed. Because I will not volunteer at all. Okay. I mean, I'm one of those people that will crawl underneath the desk so I don't get picked on. To crawl underneath the desk? Okay. All right, so you ready? So if I give you the antiderivative, you got to give me the derivative. Ready? So I have this. F of x equals 3x to the fifth plus 7x squared plus 11. What are you going to give me? Okay, f of x equals 15x to the fourth plus 14x. That it? Okay, super. Now you have a choice, because I don't know. I think first period they don't want to be mean. I don't know if this class is that way. We'll find out. So you either can pick somebody, so you can either ask for a volunteer, pick somebody, or have me pick them. So you have three choices. Okay, what do you want? Okay, so you get to pick the volunteer. Kyle. Kyle, ready? The derivative is the square root of x plus the cosine of x. So the antiderivative would be what? You need a hint, or can you do that baby in your head? Perfect. So let's take a look. So you knew this was to the 1/2 power is my guess, correct? And you said that's x to the 1/2. So if I add 1, I get 3/2. I got to multiply by the reciprocal. And then antiderivative of cosine of sine. If I take the derivative of those, sure enough, I get that. Everybody okay? Okay, so what are you going to do on this one? Volunteer. Aaron, okay? Do you need a hint? Yeah. Do you need another hint? Ooh. Okay, ready? Okay. So you used what rule? Chain rule. Would everybody agree? This is like this in parentheses. So you take the derivative of the outer. In fact, the chain rule is by Aaron and Nikita, correct? I don't know what happened there, Nikita. Just a brain malfunction. Okay, and if you take a look, it says take the derivative of the outside, keep the inside function the same, but multiply by the derivative of the inside function, which that's where the cosine x comes from, because he takes and multiplies by the derivative of the cosine of x. Perfect. Okay. Alrighty. Next. Volunteer. Cameron, you ready, Cameron? Sure. Okay. F of x equals 2 secant squared x plus 3. So what would the antiderivative be? Yes! Yes! Very good. Yes! God, I yelled that first period too. You know how hard that is to get you guys to remember that? Oh, I cry sometimes when I get home.
2 tangent squared x.
Oh, not squared, just 2 tangent x. Okay?
And then plus 3x. Plus c.
Let's see. Beautiful, beautiful, beautiful. Alrighty. Now we're starting to get to math humor. You have a question?
Yeah, why would you not do anything with the 2?
Let me back up a little bit. Would you do anything with the 2 if you had this? No, for the same reason. Because you're not dealing with powers here because they're trig. So you get 2 sine x plus c. All right. So how are we going to do this next one? You want me to pick it? Okay, I'm looking for volunteers. Have you gone? Well, then you can't. Have you gone? Okay, you ready? This is starting to be math humor. Okay? Which is sad. Okay? You know why I find this one's funny?
Why?
Because I asked what the derivative was before. So when I wrote this, I started laughing.
So it would be 2 x to the negative 1/2
Yes.
minus sine of x.
You're almost there.
2x to the negative 1/2.
I think it's 1/2. This isn't this x to the 1/2.
Oh yes.
So you can take 1/2 times 1. Okay. This next one's even funnier. It doesn't take much. How do you want to do this? Look for volunteers. Okay, volunteer. Ooh, you got 3 to choose from, which is a good sign.
Oh, Brady can take it.
Brady, you ready?
Sure.
I love this problem. I laughed for about 15 minutes. Now, everybody that knows the answer, don't spoil it. Would you like an easy hint? I'm going to, ready? Okay, here's my hint. Because I anticipated this. It's an, what? No. Okay. That wouldn't be that nice. Okay. It's an easy 1. Shh. Hey! Ixnay on the mumbling A. Do you know what cosine squared x plus sine squared x is equal to? What is the antiderivative of 1? You're not done yet. Because this is now, yeah. Remember, Friday is 3/10 of a point, folks. That's it. That's why I thought that was so funny. I thought about giving that on a, it is on a test. And you guys will forget. And you guys will say, hey, can we have 15 more minutes? Because we're stuck on this one right here. And there'll be pages and pages of your work. I really enjoyed that moment. All right, ready? Brady, what are you going to do here? Volunteer? See how they've diminished because it's, have you gone before? We can't then. Gabby? Okay, ready, Gabby? F of x equals. Now they're going to start getting hard, folks. So we're going to get scared. Okay? So Gabby, you got to give me the derivative. That's a 15, isn't it? Does it not look like a 15? It doesn't look like a 15? I need to make it bigger? Does it look like a 15 now? Okay.
Using the chain rule, it would be 15 times the quantity of 2x squared plus 1 plus,
Not plus.
oh,
I need a power first.
to the 14
Times.
times
It's always times. Times what?
4x.
4x?
Yeah.
Okay. Could you have said this, Gabby? 60x 2x squared plus 1 to the 14th power? Okay, because 15 times 4 is 60. Okay. Very good. So this is created by the chain rule, correct? So if I were to go backwards, that 15 and that 4x would not exist in the original function, correct? So if this was a derivative, its antiderivative, this chain part, disappears because it wasn't there originally, correct? It's the chain rule that created it, correct? All right. Now, do you want to volunteer or you want me to pick somebody? Want me to pick somebody, okay? Does anybody want to volunteer this next one? Very good. You ready? Okay. Right here, f of x. Can you see it okay, or do I need to make it bigger? Okay. F of x equals 2x parentheses x squared plus 1 to the 5th power. Does that look like a 5? I hope so. Yeah, it does. And what I was talking to Gabby about is a big hint. In other words, this was created by the chain rule. Back up here. Say it again. X squared plus 1. You want me to put parentheses here? Yeah. Okay. Okay. Anything else? Nope.
Plus C.
Got a plus C. You got one more thing you need. You do need something in the front. You're doing really well.
1 over 6.
1 over 6. Did you figure that out, or did somebody speak to you? Okay, let's check. If I take 6 times 1 over 6, I get 1, correct? Right? This drops to 5, correct? And then I go inside here and multiply by using the chain rule, and I get 2x out front, right around the right side here, which I could bring out front, and the C disappears. Yes, sir?
Did you just forget the C's on some of them?
No, because on some of them I'm asking you to take the derivative, and they had no constants that I was adding. Like right here, I asked Gabby to take the derivative. Okay? So the ones that have the C's are where I started with the derivative and we went to the antiderivative. Does that answer your question? Okay? You want to pick somebody or you want me to pick somebody? Okay? I'm going to pick Ellie. Okay, Ellie? All right. F of x equals. Now this one I laughed also. Okay, you'll probably see why. 3x squared times x cubed plus 3 to the third. Yeah, because of all the threes. F of x equals. Like my son Sam says, is Dad the only reason? Well, on the one day he may call me Dad. He usually doesn't call me Dad. Dad, the only reason you think the only reason people think you're funny is because you think you're funny. I'll give you a hint. Parentheses. Yeah. To the fourth. Plus C. You're doing wonderful. Just need one more thing. No, it's not x over 4. It's something over 4. It's 1 over 4. Let's take a look. I'm going to take the derivative. You ready? 4 times 1/4 is 1. X cubed plus 3 to the third times 3x squared. Is that what I have here? All right? So the check is really quick. You want me to pick or you want to pick? Okay. I'm going to pick Carter. Okay. Very rarely pick the people up front. Okay. So I got f of x equals 4x cubed x to the fourth plus 9 to 6. Now, these are all chain rule problems, correct? Now, I'm not going to yell out during the test, hey, Josh, it's a chain rule problem. Okay? How could Josh know it's a chain rule problem? Is there a way to say, hey, I know it's one? Is there an indicator? You know this is a derivative, correct? Yeah, it's a relationship of, that's a good point. You're right, it has parentheses, okay? I agree with that, and something else. Parentheses is the first indicator. I would agree with that 100%. What else am I looking for? Or what else could be an indicator for somebody to say, hey, this is the chain rule? What exists outside those parentheses? I agree. What else? Right, this derivative, right, this is the derivative of the inside, correct? If the derivative exists on the entire derivative of the inside, it was created by a chain rule. Does that make sense? This thing is related to that, this whole thing, correct? Because the derivative of the inside is this. Then you know this derivative was created by the chain rule. So you have to reverse that chain rule process, which means that baby will disappear. Right? That's the part I did a poopy job explaining. People say, where did it go? Well, it wasn't there to begin with. I'll give you an example. So my youngest son now, he'll be 26 this summer. There's a picture of our family when my younger brother got married. Mitch is not in that picture. And it was really interesting when he was 5, he was looking at the picture and says, where am I? You weren't there to begin with. right? You're number 3. You were born after this event. So where does this go when it goes backwards? It was created by the derivative process. So if you go prior to that process, it shouldn't exist, should it? So what are we going to get here, Carter?
1/7 times h to the 4th plus 9 to the 7th power plus c.
Okay, perfect. Kind of getting the hang of it, folks? Alrighty. Parts of an integral, I need to go through some things. First of all, this little doodad right here, the d of x, is a width of a rectangle. This f of x is the height of a rectangle. It's given a specific name. Well, it's called the integrand. It is always, always, always a derivative. And these things here are called limits. And the top one is an upper bound. And the bottom one's called a lower bound. And I think I've used those words. So right here, this is my derivative, formed by the what? Chain rule. So it will be the antiderivative with g of x inside it. Notice in each of the ones, the one that Carter gave us right here, I'll slide this down a little bit. There's g of x. It's inside the antiderivative, isn't it? The antiderivative of raising something to the 6th is 1/7 to that thing to the 7th power. And inside it is g. Liz. That was very good. Backside. All right. So there are 2 ways to do these problems. There's pattern recognition. So I describe myself as a blue-collar math person, which means I had to work and still work. I do every problem to make sure I understand. Okay. And in my class, I had Pat Carter, Joe O'Connor, Anita Egler, Brian Martins. And those were people that could look at a problem and already knew how to do it. And they could do 0 work and get A's. That was not me. All right? So what I have is I have pattern recognition. It's if you can use your head, use your head. If you can see the pattern and come up with a solution and it's correct, keep doing that. Now, when you do pattern recognition and they ask you to use substitution, they are one and the same thing. Does everybody understand that? The problem with pattern recognition is sometimes we don't recognize what the answer is. So we have to have a method to be able to do that. I'm going to show you both. How do you decide which to use? whichever gives you the right answer. So there are some people that are going to use pattern recognition every single time. There are other people that are going to use substitution every single time. They are one and the same thing. Both of you will get them correct, and you just got to live with there are those people that just see the answer in their head. They see the pattern. Okay? You may be able to see some of the patterns. So I take a look at this, and I see parentheses like Carter said. So the next thing I look, in this, I know this is the derivative. Does the derivative of what's inside these parentheses exist in this derivative? Inside here is x squared plus 4. Its derivative is 2x, which is right here. So I can write this as x squared plus 4, raise it to the third power, because I'm doing the antiderivative. Multiply by 1/3. Add c. Am I done? Yes. I can check. 3 times 1/3 eliminates the 1/3, doesn't it? The 3 goes to 2. And then I do the chain rule and I get 2x. Now that 2x could be in front, but it's multiplying, not adding. I'm ready to go to the next one. Everybody see this? I got parentheses again. I look at the derivative. The derivative is a negative 4x, which exists. So my answer is going to be 1 minus 2x squared. I'm going to raise it to the 4th power. I'm going to have 1/4 out here. I'm going to write a plus c. Because by God, I'm going to get that 3/10 of a point. I look at this next one. Ooh, I got a 1/2 out here. Half scares me. So I move it out here, which means I will deal with it at the end of the problem. And I have this. So temporarily, now notice I say temporarily, and sometimes when I say temporarily, unfortunately, it means permanently, which means I get it wrong. Temporarily, I'm going to forget about that 1/2. Okay? And then I'm going to say, all right, x squared 2x. So I can write x squared plus 4. Raise this to the 4/3 power. Because 1/3 plus 1 is 4/3. And then write 3/4 here. Now, Hillary, that's not my answer. Because when I lift up my finger, lo and behold, I multiply my answer by 1/2. So I'm going to take 1/2 times. This is saying 1/2 times your answer. So I'm going to get, I'm going to write my plus c so I don't forget that. 3/8 x squared plus 4 to the 4/3 plus c. And I'm going to look. 4/3 times 3/8 is 1/2. Right? It's 12 over 24, which is 1/2. This will drop to 1/3. I multiply by 2x. But 1/2 and 2x, bam! They simplify to 1, don't they? Okay. Allie, okay? All right. Now, this is not a polynomial. It's a trig function. It has no exponents. It has parentheses. The derivative of 5x is 5. What's the antiderivative of cosine? Tangent? Cot? What is it? Is it cosine? Sine. Is the derivative of sine cosine? Yes. Of 5x plus c. Now I take the derivative. The c will die, right? The derivative of sine is cosine. Then I come in the parentheses, I take the derivative of that, and that's where that 5 came from, right? It wasn't there to begin with. It was created during the process of taking the derivative. It wasn't there to begin with. Now, same thing. I'm going, oh, I need a what here? I need an 8x, and I don't have one. You see, it's like we do this all the time as math teachers. We're told, you want to be a math teacher? Start out with easy problems. Make them feel confident, and then just slam them. Make it hard. Just throw knuckleball, curveball, slider. Put linemen that are 5,000 pounds in front of them. Not anybody that weighs 100 pounds. Something hefty. So what are we going to do here? Well, what I'm going to do is I'm going to put the 8x here. But out here I have to have a 1/8. And then have 4x squared plus 3, the second dx. Because it doesn't change the problem when I multiply by the reciprocal. Everybody understand that? Now I'm going to, again, Hillary, cover up the 1/8, right? I'm going to do that at the end. So it's kind of like this one, right? But I had the derivative there, right? But here I don't, so I do algebraic manipulation. I multiply and multiply by its reciprocal. So I'm going to get 4x squared plus 3. I'm going to raise it to the third power. I'm going to write the 1/3 here. And now I'm going to include the 1/8 plus c. So my final answer is going to be 1/24, 4x squared plus 3 raised to the third plus c. Yes, sir.
Where did the 8 come from?
This 8, if I come in here, inside these parentheses, I know I need the chain rule. I take the derivative, I get 8x. There's no 8 here. So I multiply by 8, which I can do as long as I also multiply by 1/8. Because really I'm only multiplying by 1.
But why do you need to do that? I mean, why do you need to take the derivative?
I didn't quite hear what you said. I think it's a great question. I just want to make sure I hear it correctly.
Why do you have to mess around with that? Why can't you just do the answer right?
Okay, let me just back up. I have parentheses, correct? I have a function that exists in that parentheses. I need its derivative outside those parentheses. I have part of that derivative, I have x. What I need is 8x. So what I do is I multiply by 8, but I only can do that if I also multiply by 1/8. When I check here now, Aaron, watch what happens. I will take 3 times 1/24 and get 3 over 24, correct? Which simplifies to 1/8. And then this will drop down to 2. And then I'll take the derivative of this, which is 8x. And then that 1/8 and that 8 from 8x will simplify, and I'm back to this original problem right here. And if I didn't have that, I wouldn't have that nice simplification that comes through. Does that answer that? That's a really good question. Because of that coefficient of 4. Exactly. Okay, we're going to do more of those. All right? Now, the problem with the last one is I can write it like this. There's my parentheses. And the derivative of parentheses is 2, correct? Right? And I got an x here. Now what do I do? No. Yes. Well, okay, it's a function, correct? I have to figure out the antiderivative of terms of x. I got to figure out the antiderivative of that too. I'm going to show you how substitution will solve that for us. Okay? Right now, I dk. It only took me 2 years to figure out what that meant. I finally asked, oh, I hate asking my kids. They're so cruel. I don't know. That's what they said to me. I said, what does IDK mean? I don't know. What do you mean you don't know? Dad, I don't know. And I got mad at them. And then I realized, oh, it means I don't know. How much time do I have? A minute. And we're putting stuff away already. You know how Norm would think of that? You're putting stuff away. Dad, I'm putting the tools away. Like the sledgehammer. My dad was not like me. He was extremely organized. I'm like my mother. My mother had a sewing room, and she was a great seamstress. You walked in there, and all you saw was material.